mental effort here. Negative 10, positive 12. Okay? Third one goes down the other side. That's the factor 8. But strategically, so that the factors divide evenly into the far right numbers. What's it going to do? 4 and 2? 2 and 4. Oh, 2 and 4. Okay, 2 and 4 will divide evenly. Very good. Hey, you try anything else you want to. Nothing else is going to work. 2 and 4 is the only configuration that works. Number 4, fill in the blanks. 2 times -5, 4 times 3. I got my coefficients right there. Hey, what's my first binomial?
2x plus 3.
2x plus 3. And the second one?
4x minus 5.
Got it. How about that? Not bad at all, huh? Now keep in mind when you're working your test next week that that was kind of a hint, wasn't it? Yes. When you're working your test next week, I will not say use the tic-tac-toe method to solve this. All right? I will just give you a trinomial to factor. If you want to use trinomial method, if you got another method, go for it. I really don't care what method you use to arrive at your binomial products, so factors. So it's up to you. But this is a tool you can keep in your tool chest just in case something like that shows up. Yes, ma'am?
If you have a trinomial, because like you said, there won't be any specific use this or that. If you have one that just so happens to be like a perfect square trinomial or something like that, but you don't recognize that, so you don't use that crazy U.
Yeah.
Will this still work?
Yeah, it'll still work.
So if you forget that crazy U plus V formula
Yes.
that I never can remember, you can just do this.
Absolutely. This will work. Hey, this will work even if you have a 1 in front of the x squared. This will work anytime. So this is a universally used. Okay. Yes, you go.
Can you go over step 3 again?
Yes. Okay, step 3 is to factor 8. Factor whatever A is. But that could be 8, 1, 1, 8, 4, 2, 2, 4, right? So, but only one of those factorizations will give you factors that divide evenly into the far right numbers. So like 8 and 1, 8 didn't divide evenly into 10. 4 and 2, 4 didn't divide evenly into 10. All right. So the only one that will work is 2 and 4. So since 2 divides evenly into 10, 4 divides evenly into 12, that's the configuration I want. And then fill in the blanks. 2 times -5 is that, 4 times 3 is that. We got everything filled in. Okay? It's just an other method to have at your disposal, just in case you would like to use it. Anything else? Any question else here? All right. Let's look at one other type of factoring that you're going to need to be familiar with. And when I say familiar with, I mean just know that it's there, and either put it on your 3x5 card, or I wouldn't use memory bank space to memorize this guy because it doesn't show up very often. Let me go back to last Thursday, a long time ago, but let me go back to that and ask you this question. True or false? Difference of two squares factors.
True.
True, right? Okay, true, false. Sum of two squares factors.
False.
False. Prime, right? On the whole, the sum of two squares is prime. Well, we're going to be looking at the sum and difference of cubes, and they both factor. Okay? So if ever you see the sum or difference of cubes, you know it factors. And the question is not does it factor, the question is simply how does it factor. So let's look at the sum and difference of cubes. They will factor. Sum and difference of cubes will factor. And they both factor in predictable form. Both factor into a binomial times a trinomial. Every single time. Now, to be able to fill in the blanks for these binomials and these trinomials, I need to know a specific thing. I need to know what the cube roots of these terms are. So, for instance, x cubed, the cube root of that guy is x. In other words, the thing you multiply 3 times to get it, it's x. The cube root of 8 is
2.
You got to know that. First of all, so you can recognize this thing as the difference of cubes. And secondly, so that you can find the cube root. So these guys, x and 2, are going to be the players in my drama, ladies and gentlemen. They're going to be the ones that fill in to the binomials and the trinomials. Yes, ma'am?
You know, like, you have to have a subtracted sign somewhere in there. Does it necessarily have to be in the first parentheses or in the rest of the problem?
We're going to talk about that. All right. Here's the way. These two guys, the cube roots, they're the terms in the two binomials. Just put them in there. X, 2, 2. Okay. X and 2, X and 2. Your cube roots are the terms in your binomial. And the sign of your binomial is the same or the opposite of the expression. It's the same. It's the same. So if this is a difference, your binomial is a difference. If this is a sum, your binomial is a sum. So far, pretty easy, huh? And it stays pretty easy. The first term in your trinomial is the first cube root squared. So it's going to be x squared. And the last term in your trinomial is the second cube root squared. So it's going to be 4. And a square is always positive. So it's going to be plus 4. And to get your middle term, I simply multiply the two cube roots together. So, 2x. A very good question. All right. Anybody heard of this soap? Use of soap here? That's it. This is a handy little... Watch this, ladies and gentlemen. When you're factoring the sum or difference of cubes, your signs are the same, the opposite, and always positive. The same, the opposite, and this one's always positive. So for a sum, it's going to be the same, the opposite, and always positive. How about that? I just learned about soap last year. I've become a much more popular person since I learned about soap. Learned about deodorant a few months ago. Toothpaste last week. So I'm doing really good. So, all right. But soap will help you, ladies and gentlemen, in more ways than one. Same, opposite, always positive. That tells you exactly what the signs are going to be in this configuration. So if I remember, take the cube roots. They show up here and here. Square the first one to get that. Square the second one to get that. Multiply them together to get that. And then my soapy signs, same, opposite, always positive. Let's do another one. Let's imagine that you have one presented to you like this.